Alright, we are working on a laboratory. It's talking about the morphologic variation of populations. Now this goes with our data processing unit. It's very important. What I'm trying to do is give you guys examples on some different ways of processing data. Now the lab is actually simple. We're counting out 100 beans and we're measuring the length of the beans. And we're going to try and figure out some different things about the beans. So we make a data table right here. And here we can record our data. You can use this table. You can do something else with it if you want, okay, in order to record the data. That's up to you. Then I wanted you to make a bar graph. Okay, you can get rid of this whole grid and put your own bar graph in if you'd like. Okay, it's up to you. Or you could just use this system. We're averaging the data, and this is going to tell us some different things about the data. The hardest thing that we're doing is calculating standard deviation. And I want you guys to really pay attention to this, because this calculation, it's not hard in terms of like mathematically hard, it's just tedious. Okay? It takes a long time. So here's how we do this. We're going to take all of our data and write it down in these columns. Okay? So I'm going to put some numbers down in these columns to try and mimic the data that we have. We're just going to use a partial set. I asked you guys to collect 5, okay? Or 100. I'm going to put down 5 numbers. Okay, so we have 5 numbers here. One of the things in the standard deviation calculation that we need to figure out, that we need for this calculation, is the mean. So we can calculate the mean of our set. I asked you to do that above. We'll do this really quickly. 10 plus 11 plus 12 plus 12 plus 11. And we'll divide that by 5. And that gives us 11.2. Okay. So the next part of this is we need to take each one of these little x's. This is what it's saying. It's saying little x minus big X. Big X is the mean. And then we write down the number here. Okay? So if our big X is 11.2, we take the little x minus the big X, and we write that number down here. So we'll do that really quick. So 10 minus 11.2 gives us negative 1.2. Okay, 11 minus 11.2 is minus 0.2. Okay? And we take 12 minus 11.2. It's going to be 0.8. Same thing, 0.8. And then we go back here again. It's back to 11. So that's going to be negative 0.2. So we're saying everything in this column here, everything in this column, when we calculate that number, that's now a D. If we say that's what it is, it's little x minus big X equals D. Okay? So the next thing we do for the calculation is we take each one of these numbers and we square it. Okay? So we have to square each one of these numbers. So we take negative 1.2 squared. And it gives us 1.44. Negative 0.2 squared. Let's do that. Negative 0.2. It gives us 0.04. So we go the same with 0.08. 0.8 squared is 0.64. And then we come down here, we already calculated that, it is 0.04. Okay, so this is where it gets tedious, you guys. We write down all of our little x's here. This is all of the measurements of the beans. Then we process it here, every single one, by subtracting it from the mean. And we take that answer and we square it over here. The next thing we do is it asks us, it's y equals the sum of all d squared values. Okay? The sum is we add up all of these values. So it's 1.44 plus 0.04 plus 0.64 plus 0.64 plus 0.04. Okay, and that gives us 2.8. Okay. Casey. All right. So right here is the equation to calculate standard deviations right here. And I wrote it down in a script. The original script right here, this is what you would plug into your calculator if you wanted it the calculator to do the work. But if you just want to go through the steps by yourself on paper, you can use this one, this version here. It's the square root of y divided by n minus 1, and that equals z. And that's how we're figuring out the standard deviation. And if you remember from my previous video, the z is the space. It's the amount of space between the 50th percentile line and the first standard deviation. And it's the same amount of space that goes from the first to the second and all the way down the bell curve. Okay? So what we're actually figuring out is how different each of the beans are. Okay? So we'll start our calculation. We just figured out y. Y is 2.8. And we divide that by n. N is the sum of all observations. For this case, we only took 5 observations. For your lab, you took 100 observations. Okay? Excuse me. Alright, so we can reduce this. 2.8 divided by 4 equals z. So now we'll do a little math here. 2.8 divided by 4 equals 0.7. So the final answer, when we figure out z, what we have to do is we take the square root of 0.7, and that gives us the final answer. So we hit the square root button, and z equals 0.83. We'll round up, 0.84. And that's our answer. That's how we do the standard deviation calculation. Thank you very much.